Hi again. So we are continuing to work on slope. And today we're going to be working on page 674 in your book. And we're looking at problem number 11. So 674, problem 11. And that's on the very, very left side of your book, grade of a treadmill. So the problem says, during a stress test, a physician may change the grade or slope of a treadmill to measure its effect on heart rate, which is the number of beats per minute. Find the grade or slope of the treadmill shown below. Excuse me. Excuse me. Okay, so finding the grade or the slope. So if you remember, we've talked about the slope as being the rise over the run, and we've also used y2 minus y1, x2 minus x1 to help us find slope. And so what this is saying is the grade of the treadmill, 5 feet over 4 feet. So basically this is the rise of 4 feet, and the run is 5 feet. And they're asking for the grade. So when you're looking for grade, you're asking to find what's the percent of the slope? What's the percentage? And so basically you're just going to change 4/5 into a percent. So you could do this as a proportion pretty easily, because you could put the 4 over 5 is equal to x over 100, x being the percent. So let's go ahead and do that. So we have 4 times 100, which is 400, and then divided by 5, and we get, excuse me, 80%. So the slope would be a grade of 80%. Okay, same idea. Let's go ahead and look at page 675. So this is page 675. And again, we're looking the far right this time at number 12. It says, Daryl, a mason, graphed data from a recent day's work. Use the following graph to determine the slope or the rate of change of the number of bricks he can lay with respect to time. So this time we're looking for the slope, which also could be a rate of change. And you can see from the graph, make sure I did that one right. Actually, this is the wrong graph maybe. Let me check. No, it's not. Okay, so I've got the time at the bottom, 7 o'clock, 8 o'clock, 9 o'clock, 10, 11, 12, 1 o'clock. And then on the y-axis, 50 bricks, 100 bricks, 150, 200, all the way up to 400. So I spaced them by 50s. And this says at 9 o'clock, he can lay 190 bricks. 9 o'clock, 180 bricks, which would be about right there. And at 11 o'clock, he can lay 380 bricks. So 11 o'clock, 380, so I'm off my graph again, so I have to do a little guessing. So you can see that it looks like a positive slope. So 11 o'clock, 380 bricks, and our second was 9 o'clock, 190. Okay, so let's make this be 0.1 and this 0.2, and let's use the slope equation. And remember, the slope equation is y2 minus y1 over x2 minus x1. So go ahead and do the math. I'll do it as you're doing it, and hopefully we're going to come up with the same thing. other way. So I got 190 over 2, positive slope, which makes sense with our graph, and then 190 divided by 2 to reduce this. Let's see, 2 goes into 19, 9 times. And 2 goes into itself once. Okay, so our slope would be 95 over 1, which basically would mean like 95 bricks in an hour, I guess. And the question that they were asking is the number of bricks he can lay according to time. And so I reduced it down to 95 over 1, which would be 95 bricks in 1 hour. Okay, and we have one other story problem. So this story problem is number 13 on page 676. And it has to do with the Sunday newspaper. Use the following graph to determine the rate of change in the circulation of Sunday newspapers since 2005. So we started 2005, 2007, 2009, 2011. And then on my Y graph, or my Y axis, I have the circulation in millions. So this would be 30 million, 40 million, 50, 60, 70, 80 million, and so forth. Okay, so we're given a few numbers. And you can see on the graph it says 2005 there were 55.27 million papers distributed. And then in 2009 it looks like there were 46.85 million. Those points didn't come out when I first wrote them. So again, we're going to find slope mathematically. Let's go ahead and make this 0.1 and this 0.2 and do it mathematically. Remember, y2 minus y1 over x2 minus x1. Go ahead and do the math, and I will do it at the same time that you're doing it. Okay, so hopefully when you did your subtraction with your slope equation, you got a negative 8.42 million over 4 years. And so we would go ahead and find the rate per year. So to find the rate per year, we would divide 8.42, negative 8.42 by the 4 years. And so when we do that, we get 2.105, which is a negative because a negative divided by a positive is a negative. So that's about a negative let's round it, negative 2.11 million decrease in newspaper sales. Okay, so those were the 4 story problems that I wanted you to do. And so now we're going to just move on to a couple of other things. So again, looking at that sheet that I gave you the other day, my computer keeps turning off. We're going to look at numbers. Oops, come on. Sorry. This isn't cooperating. We're going to look at number 6. And it gives us the equation y is equal to mx plus b. Okay, so this equation is such a great equation because for linear lines, we go back to this all the time to solve them, to figure out what the y-intercept is, figure out the slope. So it's just a great equation. So when you're writing this, it represents a few important things that you need to know. The m is going to be a number, and that m is going to represent the slope. And you could kind of tell that in the last few problems that we did and maybe a few others as well. The b is the y-intercept. The y-intercept, remember, is going to have 0 as a coordinate and then some number. Okay? And so if I had y is equal to 3x plus 2, this would mean the 3 is representing the m, so the 3 would be the slope. The 2 would be the y-intercept, so that would be the point 0, 2. When you have an equation written just like this, it's great because now you can go ahead and graph that line easily. And so I would first start with my y-intercept, which is the 2. The point is 0, 2. And then I would look at my slope, the 3. And because it doesn't have a number underneath, I know that's a 1. So the slope then would be 3 over 1, rising 3, running 1. So I could go up 3 from this point, 1, 2, 3, and then I could run 1. Because it's a positive slope, I know I need to go to the right. Because you can see, oh yeah, it's lifting from there. I could find another point by using this first point, 0, 2, and I could fall 3, and then I could go to the left 1. I could find another point 2. I could fall 3 more, 1, 2, 3, and then go to the right 1. So that I could graph this. And now I have my line, okay? All right, so let's look at the example that I gave you in number 6, where you have y is equal to 5x plus 2. Okay, so remember our original equation is y is equal to mx plus b, which you should memorize. The m in this equation is represented by the 5, and the y-intercept is 2 again. I think that's what it was last time. Okay, so we again would start by graphing the 0, 2, and then we would use our y-intercept of 5, or not our y-intercept, our slope of 5, sorry. So this would be 5 over 1. So I'm going to fall 5 first, and then I'm going to go over 1. This again is another positive slope, so we go 1, 2, 3, 4, 5, and then I'm going to go to the left 1. And then I could find another point by rising 5, 1, 2, 3, 4, 5, and over to the right 1. and then you could connect your points. And you can see that you have a positive slope that's moving upward. Okay. All right, good. So let's look at number 7 on that sheet. And it says find the slope and the y-intercept from each equation. So your first equation given was y is equal to 3/4 x plus 7. Okay, so we're not asking to graph, we just want to know what's the y-intercept and what's the slope. So we're going to make slope m and the y-intercept b. This is kind of a general thing we use for slope and y-intercept, m being the slope. So 3/4 is the slope, the b is the 7. I'm going to write that as a point to help us remember that with the y-intercept, the 0 comes first. Okay. Now look at your second example. We've got y is equal to a negative 2x minus 8. Okay, so for this one, the slope is, I think I heard someone say, negative 2. And the y-intercept, 0, negative 8. Okay? All right, and let's go ahead and look at C, where we've got y is equal to 3/5 x. So you probably noticed that the y-intercept is not there. It's gone, it's missing. So you have to assume when there's no y-intercept that this was a 0, which means the point would be 0, 0. Okay? So all you have then, well, you still have the point because you know that that point is a 0. Then you would have 3/5 as the slope. So you could write m is equal to 3/5, and the y-intercept, which is b, is 0, and the point would be 0, 0. Okay, and then D, we have y is equal to a negative 3. Okay, so you probably are noticing there's no slope and there's no x, because remember we have y is equal to mx plus b, so the x is completely gone. And so what happened was y is equal to, maybe the slope was 0, well, okay, the slope was 0, and 0 times x would be 0, which just leaves us with a y-intercept of a negative 3. So in this case, you would write m for the slope is equal to 0, and then b is equal to a negative 3, and that point would be 0, negative 3. All right, and E, we have x is equal to 3. So for x is equal to 3, it looks different because we don't really have the slope, we don't really have a y. All we have is x is equal to 3. And so you can assume then in this case that the x-intercept is 3, which would be the point 3, 0. And this would be an undefined slope where you would plot the point 3, 0. So let's say that would be right here. And then you would have a line that would be undefined. So you would have points like that would all be 3s. Okay. And then let's look at that last one, which is F. So for F, we've got 4y is equal to 9x minus 7. So what we need to do with this one is we need to rearrange it so that we have y is equal to mx plus b. Now obviously there's not a b or an m here, and so the m is going to be the slope and the b will be some number. But we have to rearrange it so that we have the y all by itself. Okay, so to do that, to get the y all by itself, we would just divide by 4. Which means we need to divide everything by 4. So we've got y is equal to 9/4 x minus 7/4. So then the number in front of the x is the slope, so we'll call that m. So m is equal to 9/4. B is the y-intercept, and so b would be a negative 7/4. And of course, the actual point would be 0, negative 7/4. For tests and things, I kind of don't use points like this because it's kind of hard to graph a negative 7/4. Okay. All right, then let's see. 8 says, turn to page 674 in your book and study examples 9, 10, and 11. Then complete the problems 11, 12, 13, which are in the margin found on page 674. So let's go ahead and move to page 674. Oh wait, we did that already. We did that first. Never mind. Okay, so we are done with the worksheet. Yay! So let's see. Yeah, I guess that's all we're going to have for this video. And we'll continue with the next stuff in the next video, and we'll still be graphing.